All right, we are going to go ahead and get started. Looks like we might be a bit of a smaller group today, but hopefully that will be fun. Good. Okay. All of you were here last week. Is that right? Yes. Okay. Okay, cool. Well, then you're all already in Hex. So all good. You're going to get back into the same login that you did before, and then you'll see a fall 2024 week 4 template in there that you should make a copy of. If you run into any issues with that, just let me know. Great. Okay, so what we're covering today is part 2 of Python. So last week was part 1 of Python. So we talked a little bit about kind of what Python can do as far as data analysis, how to think about when you should use it. We talked a little bit about how to read Python code, how to understand what it's doing. We'll do more of that today. We also last week covered kind of writing and editing simple chunks of Python code for specifically for data analysis. We'll again get deeper into that today. And then we started to talk about kind of how to figure out what functions you need when you need them. And that's the place that we're really going to dive in today. So today we're going to do kind of a quick refresher on navigating data frames, just kind of a quick refresher of what we talked about last week. But we're really going to focus in on how to write your own functions. Okay, so last week we used a couple of functions, specifically word cloud as one of the example functions that we looked at. We're going to talk today about how to write your own functions. I'm going to talk a little bit about how to use the kind of Hex AI assistant or other AI assistants as you think about continuing on your data analytics journey. And then we're going to talk about taking these functions that we wrote and actually applying them to a data frame. There's kind of 2 different ways to do that. And so we're going to talk about both of those today. Cool. All right, so make sure you grab it should say fall 2024 week 4. Make sure you duplicate a copy for yourself. Anyone have any issues doing that? All good? Okay, sweet. All right, and then once you're in Hex, make sure that you hit the run button up at the top. So I've got some code in here that should look familiar from last time. This is using our library pandas to import some of the data sources that we've been using in this workshop, namely our Seinfeld data and some of our Olympics data. So make sure you hit the run all button in the upper right, and that'll load all those data frames for you so that we're ready to start writing Python. So just make sure you hit this run all button in your copy before we start writing some code in a minute. Okay. All right, so just some quick refresher on a couple of things. So data frames are going to be our the data that we are accessing. You could think of each of those as a spreadsheet. Data frames are a type of object that we're going to be interacting with in Python. There's a ton of other objects, but as a data analyst, data frame is the main one that you need to know. Function, that's what we're really going to get into today. So a function is basically just a series of steps that either we define or that someone else has defined. And it's just going to take some inputs, manipulate them somehow, and give us some outputs, okay, based on those steps. And then a library, this is how we got our word cloud function last week. A library is just a collection of functions that somebody else wrote that we are going to use. Most libraries that you'll use as a data analyst are going to be ones that are just kind of publicly, freely available. If you go to work, say for, you're doing marketing analytics for a tech company, for example, it's possible they would have some of their own internal custom libraries for things. But in general, all the stuff we're going to talk about today is publicly available. All right, just some quick refreshers on how to get into your code. What you're going to do today is just be adding new Python cells to your workbook. So you'll see this pop up in between any of the cells in your existing hex notebook here. If you hit this plus sign, you're just going to hit the Python. Oh, it's like my screenshot is from there before they updated. So you're just going to hit the Python button to add a new cell. As a reminder, how to get to each column and row of our data. Always good to like warm up the fingers a little bit with some quick code. So anytime you're going to need to get to the column of the data set, you're going to type the name of your data frame. For example, ratings data is one of my data frames. I'm going to do square brackets, and then in quotes, I'm going to type in the name of that column that I want to look at. Now, how do I get to the name of my column? I would go check the data browser, which is kind of the third icon down in my little toolbar on the left here. And I can see the existing data frames that I have. I'm going to look at ratings data. So for example, title, looks like title is capitalized. All right, so in my cell, I've just got the name of my data frame, the square brackets, my quotes, and the name of my column. All right, once I've typed that, I can do Command Enter, or I can hit this little run button, and this will give me a little preview of my ratings data that in that column specifically. Okay. It's also going to give me this little handy summary at the bottom, tell me the length or how many total rows. So in this case, there's 172 rows. All right, and then similarly, if you need to grab a row of your data set, you're going to do the same thing, the name of your data frame, followed by a dot, and then we're going to use this function iloc, I-L-O-C, with those square brackets, and we're going to give it a row number to get our row of that specific number back. So you'll notice in our little column preview, our rows are numbered 0 to 171. That's what gets us 172 rows, right? Is that we're counting from 0. So if I want to get that very first row, I'm going to do not SQL this. If I want to do a row, I'm going to do my data frame ratings data dot ILOC, and then give it any number. So if I give it 0, I will get this first one. If I give it 171, I will get the last one. Let's do that. And you'll notice that if I type a number higher than 171, for example, let's say 172, do that and then run that, I will get an error because there's no row at that address. Okay, so just make sure you're remembering that the rows are numbered starting with 0. All right. Okay. Talked about getting to your data browser. You can pop that open and close at any point. And as we make more data frames in the class, as we add columns, etc., they'll appear here as well. So you can use that to check that your new column showed up as you expect. All right, speaking of new columns, this is how we save new information to a data frame. Okay, so we talked last time about creating variables, meaning I can make up any name and save a string or a number or a list or any other piece of information to that name. And then I can refer back to it, I can do calculations on it, etc. All right, so in our analytics world, we're mostly going to be doing that in the form of adding a new column, kind of that same idea, but we will add a new column to our data set and we can save whatever value we want there. Typically what we'll be doing in that case is operating on some of our other columns, or maybe applying a function to some of our other columns, which we'll talk about later. And then I can save it to a new column in my data frame by just putting whatever text I want here in between these quotes. All right, so I'm typing here like I'm accessing an existing column, right? I've got my square brackets, I've got my quotes, but I can type in some new text here, no spaces. So you'll usually see underscores if it's multiple words, and that will add this new column to my data set. All right, so I add a new column, ratings data, a name, new column. I can just do whatever simple operation I want. In this case, we'll do something silly. Just add our season number to our rating number, which doesn't really make any sense to do, but this is a quick demo. I can do that. And as soon as I run this code, right, as soon as I hit run selected cell, I can come in my ratings data and I can see that it's added a column here called new column, right? That's my column. And I could, in fact, just get a little preview of that column if I wanted to see what it looks like. Just copy paste this first part, ratings data, new column. And if I grab that and I print it out, I see that I get these kind of nonsense numbers, but they're doing this operation, right? They're adding the season number and the rating number together. If I wanted to check that that was working, I would do my little kind of table preview function, which is always a handy one to keep in your mind. I would do my name of my data frame dot head. All right, dot head, open close parentheses. That's going to give you your first 10 rows of your data frame. All right, so I can check that my rating is 7.6, my season is 1, and then my new column is 8.6. I'm gonna check my math there. Right. Any questions about any of the stuff we covered last week? And it was kind of a quick refresher. Feeling good? Anything feel like we're missing? Okay, great. Right. Okay, so let's start talking about functions. So we already talked about this. Variables are allowing you to save some result later so that you can reuse it. All right, but what if you want to reuse the calculation itself, right? Whatever set of steps you did to get that information, what if you want to be able to save that and reuse that later? That's what a function is. Okay, so we've already used some predefined functions, as I mentioned, and then what we're going to talk about today is how to write your own function. And often you're doing those two things together. So you're going to be using some predefined functions. You're going to be putting them together in whatever set of steps or logic makes sense for what you need. And then you're putting that together into your own function. Right?
Yeah, it might be a little bit repetitive. It's like we were like writing the like lines, so how we make sure that the things that jump out it's exactly what we are like looking for. It's like is that we can only like look back and forth to the data set and our queue, or is there a more like convenient way for us to check that the results are what we want?
That's a good question. Yeah, I mean, typically, if you're working with large scale data, something that you're going to do is have a series of tests that you run. So typically, like for example, in my job, I write a lot of SQL, and so I have the set of SQL queries that I run that do the analysis I need them to do, and then I have another set of queries that run that just kind of check if things are right. Like if I'm relying over here in every row having a unique ID, I have another query that just returns true, false. Does every row have a unique ID? So there's things like that where you can kind of like run a separate set of stuff separately. You're typically only going to like set something formal like that up if you're doing a really big project or you're working on a team where a bunch of people are working on the data. Typically for small projects, usually that's just going to be kind of like you running a set of checks at the end, right? So let's say, this is my like silly example, right? We added together my season and my ratings. This is a very like simple function. But let's say you get this data, you're in your final data set, you like see this column, you're like, I want to make sure this is correct. A really common way that people check that is just kind of reverse engineer it. So I could say, all right, I want to check that the values in this new column are correct. So what I'm going to do is subtract from my new column my rating number. All right, so I would expect, right, that this calculation should give me back just the season number, right? Because all this column did is add those two things together. So I maybe do this, run this. This is kind of like a gut check, or I could like even like further kind of mathematically check this if it's a more complicated thing. So typically on a smaller project, you're just you as the person doing the analysis might just run some quick stuff like this at the end to kind of make sure it makes sense. Yeah. Question. Yeah, feel free to pop in with questions at any point. That's my normal format, but especially since we're a little bit of a smaller group today, we can chat about whatever. Cool. Okay, so let's talk about an example of a function. All right, so this is a chunk of Python code that is a function. The way that you know it's a function is it's going to start with def, which is like a definition, right? You're defining your function. And it's going to return some value. All right, so these are kind of the bookends of your function definition. All right. After def is going to be the name of your function, like a variable. You can name it whatever you want. Then you're going to have some parentheses. Your function can take however many inputs that it needs. In this case, I've got two inputs. The first input is going to be a list, and the second input is going to be a string. Okay, but they could be numbers, they could be data frames, they could be whatever. Okay, so my inputs or my arguments to the function are going to go inside my parentheses. So this looks very similar to how a function in Excel looks, for example. And then I'm going to have a colon. All right. And then everything that defines my function is going to be indented under the def. That's how I can kind of like visually tell that it's part of my function. That's also how the kind of interpreter is going to run the code. It's going to take anything here to be part of your function. I'm going to do whatever set of steps I'd like to do, and then I'm going to return, usually you're going to return the value of a variable. Right, so typically what you're going to do is set some sort of variable within your function. You're going to manipulate that variable in some way, and then you're going to return that new value after you've done all your manipulation. Okay, so let me explain what this is a kind of simple to intermediate function. I will explain what it's doing, and then we'll kind of walk through an example. So this function says, all right, we have input 1, which is a list, input 2, which is a string. What do I do with those? First thing I do is I make a new variable. I know it's a new variable because I've just got a new kind of keyword and then my equal sign. Okay, so I made a new variable, I made my equal sign, and then these are open close brackets. If you remember, a list is a series of items separated by commas in square brackets. So this is just a list with no items in it yet. Okay, this is an empty list. So I'm creating a variable and I'm just starting with it empty. Hi, welcome. All right, so once I've got my empty list, then I'm going to run a little loop. Okay, so I'm going to use the keyword for. I'm going to come up with another variable name. So input 1 is my list, right? So for this variable in my list, what this is going to do is say, if my list has 3 items, this is going to take the first item in that list, going to run through these next indented lines of code. When it gets to the end of the indent, it's going to come back, grab the second item. It's going to run these 2 lines of code on that second item, and then repeat again for the third. Once it gets to the end of the list, it'll move on to this line of code. Okay, so kind of a simple loop. All right, so within this, so it's going to take the first item in our list, and it's going to create another variable. All right, so we're adding more layers of variables here. It's going to create another variable. It's going to take the first item in the list and add my string onto it. Okay, so in this case, it's a list of strings. Okay, so I'm taking the first item on my list, I'm adding whatever my second input string was, and then I'm going to add it to the empty list that I started. All right, so think of this as like your grocery list. You're walking around your kitchen trying to think of what you need to add, and then this is where you're actually writing that item onto my list. So I have my variable name here, the thing I want to output, dot append. This is a list function that's adding, and the thing that I'm adding is this variable right here. So this manipulation that I just did. All right, so I'm going to do that for the first thing in the list, second thing in the list, third thing in the list. So at that point, my variable here, because I've been appending things, has 3 things in it. Gotten to the end of my list, so I'm going to come to this line of code, line 6. And here, I'm just going to return my list which has three things that are manipulated a little bit here. Okay. All right, were you here for last week's workshop? Okay, all right, so just to get set up, you'll want to go to this website, which is what we're using for our kind of code writing tool. Make sure you log in with your USC email or your Microsoft thing. Once you do that, you'll see a few different like things you can join. You want to look for Annenberg Digital Lounge on there. And then you want to look for fall 2024 week 4. Once you find that one, you should hover over it. There should be 3 dots and you can duplicate your own copy. You can write your code in there. Thank you. Give me a wave if you run into any issues. All right. Okay, so here's an example of using the function that I just wrote. Okay, so to call the function, which is how you use the function, you just give it the name that you designated and then whatever values you want to be your inputs. Okay, so in this case, I'm going to give it a list of just simple list of strings, just some letters, and then I'm going to give it a word as my second argument. Okay, so we could tell that my first argument is a list because it's got these square brackets. I've got a comma outside of that to indicate that this whole thing is my first argument, right? And this thing is my second argument. All right, so what is this going to return?
A cats, B cats, C cats.
Perfect, A cats, B cats, C cats, exactly. So it's gonna take this item in the list. It's gonna go back through here. It's gonna say, all right, empty list. For the first thing, that's A. I'm gonna make a new item, which is A plus cats, A cats. I'm gonna stick A cats in my little empty list. So empty list now has A cats in it. I'm gonna grab the second thing, B. I'm gonna add cats on, B cats. I'm gonna add B cats to my result, right? Repeat with the third one. And then I'm going to return my result. Okay. All right. So kind of a simple function, but you get the idea, right? I'm giving it some information. I'm doing some stuff, getting some information back. Right. Okay. So the thing that is cool about functions is that you can also run them directly on columns in your data frame. So for example, I could run that same function on the title column of my ratings data frame. I could give it another string to add on. Once again, it is cats. And the result that I would get here is a column of all the titles. So the good and the bad, the finale, whatever the title is, cats, right? That would be the result of that. Now, what's interesting about this is that this returns the same thing as this. So this is just adding a string onto our data frame. So there's kind of a few different ways that you can apply functions to your data frame. One way is going to be to sort of wrap your function around your data frame, meaning that you're giving your data frame or a column of your data frame as an argument to your function. There are also going to be functions like basic math where you can just do this way, or you can do sort of a dot, like some of our dot functions that we've used previously to apply your functions to your column. All right, but those two things are going to do the same thing in our case. All right, so, and then once you've run your function, again, you can save this to your data frame. So just by making a new column. So for example, I could say ratings data, I make a new column, updated title, and that column could be filled in by the existing title plus some string. Great, and then I see in my data browser that I've got my updated title as a column in my data. I can do the first 10 rows again. Oh, I guess I've got those here. Okay, perfect. And then you see my updated title, right? Good news, bad news, counts, adding it on, right? Okay. Any questions about what this function is doing or how we got from this to our list of A cats, B cats, C cats?
There's a function called lambda.
Yeah.
Is that the same thing?
That's a good question. Lambda functions are like a slightly more advanced concept, but basically they are a function that you define without giving it a name. So you sort of, you're sort of going to apply it in a slightly different way, and you're not going to give it a name. Typically, if you're a little bit more beginner with Python, I would recommend just creating your named functions and applying them that way. We'll get into how to like apply them. Lambda is sort of like a shortened or condensed way to write a simple function without separately sort of like defining it as a named function. Yeah. All right. Okay, so typically when you're working on an analytics project, you're working on code to answer a question. So this is the question that we worked on in the last session. We had a data set of all the Olympic athletes, and most athletes have a philosophy statement. All right, and we wrote some code to figure out what are the most common words that appear in those philosophy statements, right? Things like work hard or believe, whatever. So we wrote this code last time, not as a function, just as some code, as kind of a quick script that we ran. But you could imagine from this question, and there could be very similar other questions that we might ask. If you look at our athletes data set, which I'll do in here, I'll pop into our data browser and look at our athletes data. There's all kinds of interesting columns in here. There is a hobbies section, occupation, info about their education, their reason, their hero, their influence, relatives that they have that play the sport, something called a ritual, what other sports they play. All sorts of interesting text data is in this athletes data set. And we can see that there's 11,000 athletes in the Olympics. There's some interesting text analysis to be done here. So you can imagine that there's lots of questions very similar to this, like what are the most common words or phrases that come up in some of those other text fields? What are the most common athlete hobbies, or what are their most common rituals or heroes? Is everyone's hero Michael Jordan? I don't know. I don't know enough sports people to come up with a good example for that. But there's other stuff we might want to do. So the point of this is that a function is essentially allowing us to reuse whatever set of steps that we did before. So the steps that we did in last week's session to find the most common words, create our word cloud, for example, we can reuse those steps on a different column in our data frame, or potentially even a different data frame of different text altogether. Okay, so it's allowing us to reuse our steps. All right, so this is some code, or I think very similar code to what we wrote last week. This is how we wrote it last week, just as its own, just sort of some lines of code, or what I would sort of call a quick script. So that's what we're doing on the left. On the right is the same thing, but turned into a function. Okay, so I want to explain kind of how we get from just some code that we wrote to code that's all wrapped up in a function. So first thing to know is either way, if you're going to use a function from a library, you're going to need to import it first outside of your function. All right, so anywhere that you're going to have one of these kind of import statements, that has to come first, unindented. You just got to have that somewhere higher up in your code. In hex, it could be in the same cell or in a previous cell. It just has to be conceptually above wherever your function is. All right. So this is the code that we wrote last week. We tried just running this most common function on our title column. That didn't separate out the words, that just looked at the titles in full, and all the titles are unique. So that wasn't super useful. So then what we did is we made a variable called all words, which is another of our empty lists. We did another quick for loop, or I think we did this similar. This is similar to what we did, if not exactly what we did last week. We're going to loop through all the titles in our ratings data set. We're going to split the title into its individual words. And then we're going to loop through each of those words individually and add them, append them to all words to our empty list. Okay, so we're splitting up, we're looking at each title, within each title, we're splitting up each word, and then we're adding each of those words to our list. And then we're running this counter function, this counter all words dot most common. We're running that on this all words list that we created. Okay, so I have that copy pasted somewhere in here. Right, fantastic. Okay, so when we run this, we find that the most common word in the Seinfeld episode titles is the, which appears 169 times. Okay, not surprising, not the most exciting result, but not surprising. Okay. All right. So here is this chunk of code, and here is what that same chunk of code looks like as a function. So the main difference is I've added def, I've created a name here, and I've given it one argument. I just called it column, right? Again, this is just something I'm defining. I've done my colon, I've indented. Now these lines 2, 3, 4, 5 here are basically the same as this, right? You can see I've got all words, but it's just indented. I'm doing for title, but you'll see now instead of ratings data, bracket title, I don't have that. I just have column, all right? Because this is the name of my argument. All right, come back to that in a second. And then my next two lines are exactly the same, right? They're indented one more level because the whole thing's indented one more level. All right, but I'm going into each of the words in that title, splitting them up, and I'm appending them into this list. And then the last thing I'm doing, I've got my return. So this is telling the function what to output. And then this line is exactly the same as this last line here. All right, so in this case, this cell of code in hex printed this out just because it always prints out whatever the last line of code is in the cell. In this case, I'm going to actually have it return that value so that I could save it to a variable or print it out or whatever else. I want to maybe give it to another function if I'm doing something complicated. Okay. So the only real difference, I've given it a name, I've indented everything, and then I've created sort of a generic placeholder for the specific data frame column that I was referring to. I said, let's just put in a generic placeholder. We'll call it column. I'll pop that in there, and then I'll let people know that when they call this function, they need to give me a call. Okay. Any questions about how we got from here to here?
So it comes certain, like we just create a function, but it can't run instantly, but in code 12 that it can already run.
Yes, exactly. So this is defining our function. So what we're going to do next is we're going to call our function. So to actually use this function that we wrote, we just write one line of code like this, which is our function name, and then you can give it some column. In this case, I'm going to give it that same column we were playing with before, because I want to make sure that I'm getting the same result. My intention in writing this was to get the same result as that, just in a more kind of reusable way. So if I take this code, I see it prints out the same result, right? The, which appears 169 times in all the episodes of Titles. All right. So you can see the reason why you might want to do this is, let's say you wanted to find the most common word in all the episode titles, in all these athlete philosophy statements, in all the athlete hobby statements. If you didn't write this function, you would have to retype all of these 6 or 7 lines of code every time that you wanted to find the most common word in a data frame or in a data frame column. You'd have to retype all of this, and you'd have to substitute in here the other column that you wanted to look at. So this is essentially, and every time you're retyping that, there's more chance for typos. There, maybe you copy paste it wrong, whatever. So writing a function allows you to save all these steps, and then if you want to call this function on 10 more data frame columns, you only have to write 10 more lines of code that just look exactly like this: function name and then whatever column. So it's really easy to read for somebody else to understand what you're doing. Once they already understand this function, anytime they see this function elsewhere in your code, they'll understand what you're doing. Yeah.
About the return line.
Yeah.
What is the count? I mean, I know the counter here is like something different word.
Mhm.
Why we write this line like this?
Yeah, great question. So whenever you're importing something from a library, I don't want to get too deep into it, but there's kind of a couple different ways that functions can work. Either you're kind of giving it something in parentheses like this, or you've got a method where you're doing dot and then the name of a function. Typically, whenever you're looking up the library, you'll see a little example snippet of code that they're doing, and you just kind of copy the format. If you're going to get a lot deeper into coding, there's more technical differences between why some functions look like this and some look like this. I don't think that's worth getting into for the purposes of this class. But yeah, typically you'll just want to like look at how they're doing it and look at which ones take arguments and which ones they're just kind of empty, no arguments needed. I just copy. Yeah. Are you good with getting into Hex? Were you able to get a copy of the doc and, cool, sweet. All right. Okay, so I'm gonna have you all kind of take a stab at very similarly to what I just did, where I took a chunk of code that's not a function and made it into a function. All right, I'm gonna have you all try a very similar exercise to that. So in your little template, I copy pasted the code that we wrote last week. That should be this one. You should have this somewhere in your template copy. Right here, our code from last week. All right, that code is not a function. I would like you to turn it into a function that should take two arguments. It should take the name of a data frame and it should take the name of a column as a string. All right, and then it should print out the word cloud. All right, so you already have the code that does all of these things. It's doing it on a specific data frame and column. All right, if you look at our code from last week, we're specifically looking at our athletes data frame in our philosophy column. All right. So I want you to take this chunk of code, you could essentially copy paste it into another Python cell and turn it into a function. Okay, so you should have something that looks roughly like this. Def, give it some name, give it two arguments, and we want it to return our word cloud. Okay. Anyone feel like they have a function? Getting it? Yeah, you got something? What do you got?
I define draw word cloud.
Okay. Def, draw word cloud, all right,
And brackets and column.
okay,
Yeah, and then like absolute words equals. Just change the from like abstract data to column.
okay,
And then I copy paste the like word cloud.
great, so this whole
And
thing,
then I just copy paste more.
all right, fantastic, okay, so you copy pasted all of this.
And change the ASIC words philosophy into column.
Ah, okay, great. So here, I'm gonna copy this whole thing. I'm gonna bring it down here. All right, so you have this all indented. All right, so I took this out, athlete's data philosophy, and I put in column, right? And then everything else is copy pasted. All right, feeling good? And then at the end, should have a return.
I'm not sure. I return it.
Yeah, that's cool.
Should we return to the plot?
You can just return plot itself, actually, but let's check if I'm right about that. Okay, fantastic. All right, so we have our function. You typically won't see a lot of errors in your function defining phase unless you've got kind of like a syntax error in how you defined your function, because your function here hasn't actually run yet. Okay, so the best way to test it if you don't get any errors at your function define phase is to actually run it. So now that we've got our function, I'm going to actually run it in a new cell. I could run it in the same cell, but I'm just going to run it here to keep it organized for myself. So I'm going to type in our function name, draw word cloud. I'm going to give it a column. So what column? So I'm going to give it, let's see what column we're using before, athletes data, philosophy, right? That's the column that we were using before. All right, so I should see if we did this correctly, a pretty similar word cloud to what we had before. Okay, great. Here was our word cloud from before when it's not functionified, right? And here's my word cloud now. So the generator changes the colors a little bit, but I see that some of the same large words, right? Info, always, sport, will, right? Those are all in here.
What was the question of like how to write the return line? Like why this function returns yield?
Yes, good. Okay, so what we're doing here, the thing that word cloud is outputting to us is an object that is a plot. You'll notice in our original thing, we imported this kind of object called plot. So that's sort of like the type of thing we're returning. So instead of a data frame is a type of object. A plot is another type of object. So essentially we've created this object using our function word cloud, and that's what we've spit out. This is actually, more typically in a function, you're returning like a data frame or a specific value. So this is a little bit of an odd one in the generating an image. But yeah, it's basically just an object. Okay, so I ran my word cloud on my athletes data philosophy column. I get a very similar word cloud. Looks like it's working great. All right. Now, the way you really know your function is working is if you can run it on a bunch of different data and it still works. Okay, so I'm going to run it on a different column in our athletes data. I personally am very curious about what hobbies Olympic athletes have. Okay, so I'm going to run it on my hobbies column and see what I get. Okay, I get an error. Let's look at this error. So my error after a bunch of this kind of nonsensey stuff is saying key error philosophy. Okay. So it's looking for the word philosophy, and you'll see it's highlighted this line, athlete's word philosophy. So I've still left that in my function. All right, now I didn't get an error before when I ran it with philosophy, because that was the right name. That's the right like thing that function needs. You see it works fine, but as soon as I change the column, my function fails. So I need to make a change to my function. to address this issue? Does anyone else's function address this issue? Anyone have any ideas about what we?
You change the athlete words philosophy into column.
Okay, but we'll notice that athlete words is this other thing that we invented here. So if I replace it with column, then that means this will become athletes data philosophy,
But
right?
mine was like this and I successfully run. Yeah.
All right.
Like I do like athlete words and like this
Mm-hmm.
and then I change it to comments. Added words.
Okay. So the place that you're missing dot fill. All right, so you put column here. Right, that's the difference that you have here, okay. Okay, let's run that. Let's try this with philosophy. All right, fantastic. Okay, great. And then let's try these. Awesome. Okay. So I think what this is doing is generating a word cloud. Okay, well, let me show you what I was going to do and then let's come back to this. Okay, so in athlete words, or in this case, we could call it, I might call it something a little more generic here, like word list. All right, I want to make sure I'm giving word list to this part of the function, because what I'm doing here with word list is I'm making sure I'm splitting out every single word on its own. I'm not just running the word cloud on each whole chunk of text as its own item, if that makes sense. Okay, so so word list is going to have a column with that same column header. So when we were doing athletes data philosophy, our word list for that, if we look at our athlete words, it has sort of two columns. It has an index and then it has a column called philosophy, which is just keeping each word from each philosophy as its own. All right, we can see that because there are 11,000 athletes, but there's 66,000 rows in athlete words. So there's on average, each philosophy statement is 6 words long, right? There's more words than that. So I want to make sure that I'm giving that word list to my function, because right here, what I'm doing is I'm essentially not using this line of code. I can comment out this line of code and my function still works, meaning I'm not using it. So I want to use this because I want to make sure I'm splitting out all those words to count separately, okay? So to do that, I would want to give this my word list, but my word list is going to have 2 columns, much like my athlete words did, right? It's going to have one that's an index and it's going to have one that was whatever column I originally gave it, right? So the way that I would address this is actually to have my function take in 2 arguments. So you've given your function 1 argument, which in many cases will work, where you're just going to give it your data frame and column selection kind of together. All right, I'm going to try something different, which is to give my function a second argument. All right, I'm going to call it my data frame and then column name as my 2 pieces of information. All right, so then what I'm going to do is I'm going to do my word list piece on my data frame, right? Because that's where I want to grab my column from, and then my data frame selecting my column name. Okay, so I'm essentially separating out these 2 pieces that we had together in our first version, all right? And then in my second piece here, I know that in my word list, I'm gonna have a column with the same name as this column. So I'm gonna give that my column name, all right? All right, no errors with that. Let's try that. All right, now I'm going to get an error, but it's because I'm still giving it this argument as we had it set up before, where I'm giving it 1 argument, right? I can see that my error, draw word cloud, missing one required argument, right? Because I've only given it one. So in this case, I'm just going to separate these two out with a comma, right? I'm going to give it the name of my data frame, and then I'm going to give it in quotes the name of my column. All right, and give that a whirl. All right, cool. This gives me my data frame. I can try this with another column. Let's try this one. All right, great. Okay, so I think the reason that these are showing up as different, this one has a little bit more size variation than the one that previously came up. So I think that was previously like if they had written like reading, comma, music, comma, cooking, that was reading all as one entry in our previous word cloud. So I think this is separating out our words. I think that's what might be the difference. So depending on your use case, either one could work depending on which sort of analysis you want to do. But so I guess, yeah, so we walked through the way to do it with kind of one column, treating each column as its own thing. If we want to separate out the words within each column, I believe we need to do it this way, which is giving it two arguments, giving it our data frame name and our column name so that we can refer back to our column name in this second part. Okay. All right, did anyone have a different function or anyone do anything differently in their function? Anyone run into any errors? Right. All right. So we can run that function that we just made on any data set, any data frame that has any text column, right? So we tried it on our hobbies column. We could try it on occupation, ritual, hero. We could try it on our transcript data from our Seinfeld data set, right? We could run that function on any data frame that has a column that has text data in it, right? Which is pretty cool. Yeah. Yeah, what you got? All right, you have an error. What's your error? Scroll down a bit. Key error column name. All right, it looks like it's looking for. Okay, so you put column name in quotes here, so it's just treating that as a string. Yes, you want to take that out of quotes because then you're giving it in quotes here. So yeah, there you go. Nice. Any errors? Good over here.
Yeah, actually I have the error. I'm
just
trying to figure it out.
That's okay. Okay, unexpected EOF, that means end of file. Right, so, okay, great. So word list, you're missing what column name to tell it. All right, so this is the piece where in our athlete words in our previous version, we can see that we're gonna end up with two columns there, one called index and one called whatever our original column was called. So you wanna give it that original column name, which is handily our second function argument. So you just want to tell it in word list, look for the column named column name. So you want to give it that in there.
Okay. So just here?
Yep. Yeah. So you can just, that same column name, you could just copy paste that and stick that right where your cursor is right now.
Okay. Just whatever, which one?
Yeah, so that's your second argument.
Oh.
And you're going to put it in the square brackets. So if I go back up to online, so you can see. All right, yeah. So in, oh no, it's slightly different. Let's go up here. Here it is. Okay. So in my word list, I want to grab the column that has that same column name. So I want to give it column name in there. Once you do that, that should run. Okay, and then error compiling. All right, so everything that's part of your function has to be indented. So this whole part, you can actually select that whole chunk of text and hit tab and it'll, yeah, and then tab over, beautiful. All right, and then I think your very first line just got an extra tab.
Oh
yeah.
yeah.
Yeah, just take out one of those. All right, and then try running that.
Oh. Is that right?
Okay, yeah, it looks like we got rid of that error. Okay, great. And then let's see what we've got on our second one. Looks like, yeah, let's run that cell. Okay. And this is a name error. Draw word cloud is not defined. So let's go double check what the name of our function is. Looks like it's draw a cloud. Yeah, so you can just change it to function name can be whatever. It's just gotta match. Yeah. So give that a run. All right. Column is not defined. All right, so let's come back up. Name column. All right, so somewhere. Aha, okay. So here you've got athlete words equals column dot string split, etc. But we don't have anything named column. We have something called my data frame and we have something called column name. All right, so column, it doesn't know what that is because we didn't define it. So what we want to give it is the data frame, because what we want this all to operate on is that column of the data frame, which we get to with data frame name and then our square brackets and then our column name. So you want to give it something that looks like this, match your names of what you gave it as the argument, right? So I gave it my data frame. So I've got my data frame here. Then I did square brackets and then I said column name. So I've got column name here. All right, so try replacing that. And then I think that should probably run. Okay. Better luck? Nice. All right, cool. All right, so I'm going to take sort of a quick aside here and just talk for a moment about using, Hex has a built-in kind of AI assistant, which you can use to help write SQL or Python or whatever else. I talked about this a little bit in the SQL session, but I'll talk about it a little bit for Python because I think the debugging is a little different. You can use this with any, ChatGPT or anything else. Sort of give it a prompt. The way I'd recommend using these sorts of things is to sort of, if you'd like to use them, is to sort of treat it as a first draft and then make sure you're going back and understanding what it's doing, because you likely may need to make some revisions, okay? This is just an article I like a lot about using kind of these tools as you're learning Excel or Python or SQL or anything else. I'm not going to read this whole thing. If you're interested, it'll be in the slides that are posted after class. But basically the idea is that these tools are really helpful for kind of that like generate a first draft of your code type of thing. Typically what kind of these tools are really good at generating is, like, let's say after this class, you're like, wow, I'm like really interested in Python. Rachel's the best teacher ever. I'm gonna like keep learning Python and an online tutorial. The prompts that you get in any kind of Python class, you can copy paste into ChatGPT and it's likely going to give you a very accurate answer. Right? It's really good at those issues. It's much less good at kind of real world applications. So if you can kind of like make your way through a lot of like intro to Python content by just getting responses from ChatGPT, and they will likely run and they will likely work. It's going to be harder to do that in the real world. So if you're going to use those tools as you're learning, which you certainly can because they're available, I just want to make sure you know kind of how to look at what it gives you and how to revise from there. So I want to show you a couple examples of prompts that I gave it and the code that I got back and sort of how that works, right? So I gave it this prompt and I'm not that good at writing prompts. Okay, I haven't like looked at this. This is like a pretty amateur prompt, I think. Write a Python function to find the most common word in a data frame column. Okay, that's essentially a question I asked you guys last week in our session. That's the prompt that I gave it. Okay, and it gave me back this cell. All right, so immediately I can tell that this is a function, right? Because it starts with def, it's got a bunch of indented stuff, and then it's got a return, right? So it's giving me a function, super cool. Looks like its function is find the most common word, take a data frame, take a column, and then it's doing something very similar to what we did before. All right, it's starting a variable called words. It's applying some functions to sort of split and explode, so essentially like separate out all the words from that column as individual words. So we're saving that to this variable. Then it's running this function counter to create this result called word counts. All right, and then it's doing something here where it's setting one more variable called most common word. It's taking our word counts, and it's got this 100 thing on the end, which I don't quite know what it is because I don't know about this counter function. Okay. So knowing all the Python you know now, which is, say 2 or 3 hours worth of Python learning, you have like some rough idea of what the AI returned to you, right? You have some general idea. But this kind of needs some tweaks, right? So if you try out that function, right? So if you get it to write a function for you, you got to know how to call the function. So in this case, I'm just going to give it a data frame name and a column name, much like we just did in the function we wrote. And it's just going to give me this very first word, A. Okay. I wrote a very similar script. It kind of does the same thing. This like literally only gives us the first word though. I think in the example that we did last time, we sort of listed the most common words from most common to least common. So what I actually really wanted was the list and to see the first few. Okay. The other thing that it did, this is like an AI thing that is more common, sort of like AI error than human error. It gave this function that it auto-generated the same name as a function I had previously written. And if you give a function the same name as another function, it's going to overwrite whatever your previous function was. Okay, so that's like kind of annoying. And that's something that like the robot is not necessarily going to know. So first thing I would do is rename my function so that I still have my previous one available to me. And then I might also make some tweaks so that I actually get that list instead of literally just the first and only. Okay, so you can see it gave us some pretty useful stuff. It did write a chunk of the code for us, but I had to like look at it a little bit and make a few tweaks to kind of get it to what I wanted it to do. All right, so kind of just an example. The other thing you can do when you get code back like this, so we use string.split, but I don't know, I can't remember if we use string.explode. So if you have a function, if it gives you a function where you don't know what part of it does, I would definitely recommend that you Google or sort of AI assist that one function just so you understand what each line is doing. All right, similarly, you can kind of like split out each part. You can kind of copy paste out parts and run them on their own just to understand what they're doing and see it step by step. Okay. All right, here is a second example of this. So I gave it the same prompt that we worked on last week. I said, use Python to create a word cloud of description words. Okay, so I used that function that we previously had. I gave it the description column of our episodes. And I said, all right, give me a word cloud. All right, and it gave me pretty similar stuff, right? We can see it's importing word cloud. It's doing some of that same generation sort of stuff. But the code that it immediately gave me had an error. Okay, this is like pretty common in my experience with trying to use these tools, that sort of the immediate thing gets an error. So you still have to be able to understand what's going on with the error and kind of fix it. The tools where it reads the error and tries to fix it for you are pretty bad still. So they don't work super well.
When I like doing some like hard Python antics, sometimes I figure out that I can't understand the Python it wrote. So if that means that I just can't write that function using ChatGPT tools because I can't check.
Yeah, so that's where I would. It's a hard balance. I think I didn't have this tools didn't exist when I was learning it, right? So I don't know. What I would recommend though, anytime you have code that you don't know what it does, whether it's from ChatGPT or a colleague or whatever, is that you do this, right? So you have a bunch of lines, just kind of take each smallest part and just like print it out, see what it prints out. That is a great way to learn actually, because you'll sort of see like, okay, what does it look like after just dot split? What does it look like after dot explode? Okay, what does just to this part look like? So that's what I would recommend. That said, if you type something into ChatGPT and it gives you a big long Python thing, which is pretty common.
Most of the time doesn't work. And like when I I just copy and paste the arrow page and send it to ChatGPT, like it still sends me something that doesn't.
Yes, yeah, the error stuff is not very good, and that's harder to get right. So I suspect it'll be a while before that works well. So yeah, I think stuff to look for in the error message. It's kind of an experience thing. But you can also kind of like look for some keywords. Like I think the area that she had before was like the name, column name is not defined, right? So you can go back up in your code and kind of control F for that. So I think one of the main things is just like try to read the error to the best that you can. I think a lot of people see the error and they're like, oh no, there's an error, I can't continue.
Yeah.
But you can come down here and try to piece it out. So this one says type error, sequence item 0, expected str instance tuple found. Okay, I don't even know what most of that means. Okay, but I know str is string. Okay, so there's somewhere where it's expecting a string and it's not getting a string. Okay, so that's a conceptual understanding of what's happening with the error. That's the information that you need to fix it, right? Okay. So the way that I sort of fixed this one is figuring out what description words was, right? This code, it popped out with description words. I was like, let's go check what description words even was. All right. And so I made it a list of strings. So I essentially was like, okay, description words is something that's not working. That's causing the error. So I made a new variable myself called all words. This is the same thing we did before, right? It's going through the words in the column, it's splitting them out and it's appending them to this list, right? So I know that's a list of strings. I did that before, I know that works. So I wrote this bit and swapped that in where the AI had given me description words. All right, and that was able to fix it. Okay. So I think like just some general recommendations of like, when you do the code, it may run successfully. If it does, make sure it's doing what you think it's doing. Make sure you understand what it's printing out. And if it does get an error, often the errors are just like, they're a little weird. It's like it gave the wrong name, or it's pulling from the wrong table, or a table that doesn't exist, or it's given the same name to something that already existed, so it overwrote it, right? Just like little things like that, that you as a human would be unlikely to make that error. All right, cool. That was sort of a little aside. Let's get back to some of our data frame stuff though with our function. So the other great thing about having it as a function is that we can sort of layer in some additional kind of functionality. So for example, last week we talked about how to filter our data frames. Okay, so filtering, for example, by one of the columns. In this case, if I want to look at all of the athletes' data, but I only want to see the athletes from Ireland, I can do that. So I can go like I'm selecting in my athletes data frame, and then I'm going to put within that this condition, the athletes data country column. It's a double equals because I'm comparing, right? I'm saying, is this equal to, is equal Ireland as my country? I'm saving that to another data frame. All right, so to show you what that looks like, I'm gonna come down here. Spot, okay, great. So if I do this little filter, just to show you what it looks like, and then I run this, I see that I'm starting at index 369, right? So I can assume I'm skipping the first 368-ish rows of my data set. I'm seeing a bunch of athletes all from Ireland, great. And I'm seeing that I'm getting 143 rows out of my 11,000, right? So I'm just sort of checking that my filter worked, right? So I'm filtering for anywhere where the country equals Ireland. I could check for a different country. Let's say I'm going to check for Morocco. Spell Morocco. Great, I'll run that. I'll kind of like glance over. It looks like these are athletes from Morocco, and this pulled 61 rows. So it looks like there's 61 athletes from Morocco. Okay, so this is just me filtering our data set. This is the same data set filtering that we looked at last week. I can save this result to its own data frame. All right, so I can give it something, a name like filtered data frame. Just do my equal sign to sort of save that. And then because I wrote my function, I can just run my function on my filtered data frame. So if you have your draw word cloud function, I want you to try running it on a filtered data frame. Okay, so you can kind of copy this, you can do it, run it on just athletes from a specific country. You could try filtering on something else if you like. But I want you to try running your same word cloud function on some filtered part of your data set.
You mean the combination of word cloud and this function?
So I want this to be the input to your word cloud. So instead of all 11,000 athletes, we just want to give it these 140. So, make sense? The hint I'll give you is that this whole thing is basically a data frame. All right, this whole filtered thing is basically a data frame. So you can plug that into your function the way you would plug in any other data frame.
What should we?
Yeah, so you should do a word cloud like we did before. So of the athlete hobbies or philosophies or whatever, but instead of the whole athlete's data, I just want like filter by Ireland or Morocco or filter by something. And then I want that word cloud of their hobbies or philosophy.
What is performance? Where should we put the filter definition?
Where'd you try putting it so far?
Yeah, I try to put it like just like word list and
Mhm.
equals filter definition and then the whole like my data frame whole thing. Yeah, but it doesn't work at all.
Okay.
Try to understand it.
What about you? How you doing?
Oh, yeah.
Yeah, I don't know like why there are column name and column to filter, so I just actually I thought I wrote like filtered data frame equals data frame and square brackets, data frame column to filter equals filter value.
Okay.
Something like that.
All right. Sounds like you're getting close. Here, let's see. Let's look yours on all of yours. Okay.
Seems to work, but like I start to perplex and push.
Okay, yeah. So first, when you're for here, you're gonna want your regular parentheses, not your square brackets. Square. Yeah. So So that's what you should get you started. But yeah, so the first thing is a data frame. The second thing is the column that'll make the word cloud. So the column that'll make the word cloud hasn't changed, right? The word cloud should still be like philosophy or hobbies or something.
Oh.
Okay, so the second one should be the same. Okay, so give that one whichever one you want. And then remember that what we're doing here in this line of code is that we're saving, so we're doing this filter, right? This thing that we did created this filter, right? And then what we're doing is we're saving that to another data frame, right? This thing I made filtered DF. I can go look in my data frames browser and I can find filtered DF is in there. All right, it has 36 columns, it has 143 rows, right?
Yeah.
That's what this line is doing. All right, so this essentially is a data frame that has got the filter applied already. All right, oh man, you skipped right to here. Okay, that's totally fine. Okay, so crucially, this phrase filtered DF, that's not any of your arguments, right? That's, as far as this function doesn't know what filtered DF is, because the 4 things you gave it aren't, none of those things are filtered DF, right? So it doesn't know what filtered
Oh,
DF
yeah, I see.
is. Make sense?
Okay. I would think. Wait, what's that?
So what this line is doing is we're creating a new data frame, right? And then we're giving it this data frame that we have where we've filtered out our.
Oh.
You're both very close.
No, still. Yes.
All right. Okay, so you want to scroll past this stuff. So no, sorry, it's down. I think, yeah. Usually you get something more useful at the end of we need at least one word to plot a word cloud.
Oh, okay,
Okay,
so
so-
maybe it's the contrary.
Yeah, maybe try. Yeah, so that would be, you could do like a little preview of your data frame to see some of the country names. Yeah, you could try France. Yeah. It might, some of the countries are like the Republic of or whatever, however they're spelled in there. I don't know exactly.
Oh, maybe I just try for it.
That could work too.
No.
I think it's 2 C's, yeah. All right, give that a whirl. That's looking pretty cool. Okay, let's go along the bottom. Okay, let's go back up. Okay, so filter DF, hobbies. All right, let's go back up to your function. My function. Okay. Aha. Okay, here we go. So same thing here. So filtered. Yeah, so we haven't told it what filtered DF is.
What I do?
Well, yes, but if you're going to use your function then on some other data frame, like you can't just always have it be country equals Morocco. Okay, here, maybe let's pause. Okay, so no, you're good. You're good. This is the meat of our thing today. Okay, so the very first thing to do, right, just to get a sense of how this works, is to just run your existing function. Don't change your function at all, right? So the function I wrote before, just run it on your filtered data frame. So the very first thing I wanted you to do is just see the fact that because this is also a data frame, you can actually just plug it into the same function that you have. So you can do your filtering as its own line of code, right? And then just use your same unaltered function that we had before. And it's going to give you a slightly different word cloud, right? Because this one, So if we just look at this one and then we go back up to our other philosophy one, this one had a bunch of other words that don't show up as big on this one, right? Dream doesn't show up on this one. Okay, but best does. So that tells me that more Moroccan athletes had that word in it as opposed to dream. Okay. So very simply is sort of this, right? So we can do the filtering outside of our, we can like create whatever data frame we want basically and feed it into this function. So it's sort of one way that we can do this. It's sort of the first. Does this conceptually make sense? We did here. So this is before I made any modifications. Okay. So the next thing, which I think you both already got a jump start on, is to then create a function that essentially brings this line, this whatever conceptually this line is doing inside your function. Okay, so that's what we're working on now. So we're essentially keeping our same 2 arguments, but we're going to need to give this function 2 more arguments because we have to now tell it what we want, what column we want it to filter by, and what that filter value should be. So we have to give it 2 more pieces of information if we want to bring this line inside our previous function. Okay, so what we want to end up with is a new function. It's going to be pretty similar to our other one, but it should have 4 arguments. The first 2 are the same. What's the data frame? And what's the column that we want to make the word cloud out of? So philosophy or hobbies or whatever. And then we need to give it country and Ireland or right, Morocco, anything. Because our function as it is right now, here, there's no way in this function for us to tell it, filter by country equals this value, right? There's nowhere I can put that in the body of my function because I haven't given it, it's not going to get it from input anywhere. All right. So we should have a function with 4 arguments like this. Here. All right. With 4 arguments like this, and most of your function is going to be very similar, but we're essentially going to need to add a line to the beginning of our function that looks very similar to this line. Okay, so what we're doing, this line is filtering our data frame and saving it to a new data frame. We need to do that within our function using our kind of generic labels instead of the specific data frame and these specific names. All right, so your new function should have 4 arguments and it should have a line that looks something like this before all those other lines that it had. Right, now I think on yours, yeah, okay, great. So yeah, so this is good. So here now you just have filtered DF here. I think before you were like trying to access a column of that data frame, but that data frame didn't exist yet. So it was part of your error before. All right, so you have data frame, great, which is the name. Data frame again, column to filter, filtered value. Okay, it's looking really good. All right, cool. And then you have word list, which is using filtered. Awesome. And then you're using word list there. Okay, looking pretty good so far. All right, so what are you going to call for your additional arguments on your function?
I don't know, like, what should I put for column name? Like, if I put country, and what about column to filter?
Okay,
they
so
the same?
column name is going to be the column we pull from to generate the word cloud. So column name, so those first 2 are kind of staying the same. So before we were doing like philosophy or hobbies or whatever there. So your second argument should be philosophy or hobbies or one of those, the kind of like text you want to analyze in your word cloud. Does that make sense? Because we don't want the word cloud to just be like the giant word Ireland. Right. We don't want that to be country names. So here's one example of calling the finished function, right? So I have whatever my function name is. In this case, I made it slightly different. The name I had before plus filtered, okay? Then I'm giving it 4 arguments. I'm giving it my data frame. You got it working? All right. You got it work,
Kind of
Bob?
like effort and data. Feed
Awesome. Okay, great. Cool. All right, and then to check it, I would say now switch out Ireland for a different country name. And make sure you get a different word cloud. How's yours looking?
Arguments. Yeah,
Yeah, exactly. Okay, so the piece that we need to add, so my function is what we had before, right? So I would make a copy of this, and then I would give it like my function filter, right? I would like give it a slightly different name so that we can still get to our old function, but we can modify this one.
So should I still keep this one?
Or
is it just I wrap?
yeah, so that's just like a different thing. That's not part of our function. We're gonna add a line that's similar. So yeah, I would keep it because we're gonna kind of model another line of it. So yeah, paste that on in. Okay, and then just give it a slightly different name. Great, perfect. All right, and then you're gonna need to add 2 more kind of placeholder arguments for it, right? We need to tell it that we're gonna give it 1 more column or like filtering column, and then a filtering value. So you just need some kind of placeholder names for those. Yeah, exactly. So I think the way I had in my little template was something like this, right? Tell it that we're gonna give it a data frame, we're gonna give it a column name, we're gonna give it something to filter and something to filter. So you should have something kind of like that.
Well, this shows up when I try to enter the things, or like it won't show up just like when I.
Yeah, so these are like generic placeholders for what you're gonna put in when you run it. And then when you actually run it, it'll look like this. So it'll be an actual data frame, and then it'll be the actual strings that are the column titles and the value that you. So when you're writing your function, they're all sort of generic. You don't need the quotes because these aren't the actual strings themselves. This is just sort of like a variable placeholder.
Which is occupy space.
Exactly. Yep. Perfect. And then similarly to that, so once you've got your 4 arguments in there, then you just need a line at the beginning of your function that is sort of the generic version of this. All right, so what this is doing is filtering our data frame. So you want to do that within your function using your generic variables. So in my example, I just was calling my generic data frame. All right, so what I would want to do in this line is replace athletes. So I brought a copy of this line into my function, but I don't want athletes data in my function. I want to refer to a generic data frame, not that specific one. So I would replace this. Anywhere athletes data shows up, I would replace with data frame with just my generic placeholder word for the data frame. And same thing here. So instead of country, I don't want it to say country specifically. I want it to have that generic placeholder for my column to filter by, whatever I named that. I want that between the brackets instead of country.
It seems to be like, it's like the circle that, since I tried to define like my data frame here, but it's like, so I need to.
No, so you need to make a copy of this, copy paste this. Put it inside your functions, make the first line of your function after the call. Yep, perfect. All right, great. Yes, and then here, so here you want it, my data frame is correct, but you want to replace athletes data here also with my data frame. Right, because we don't want it to always come to athletes data, we want it to be that one. And then Yeah, perfect. And then country, you want to replace with whatever the. Mhm. Yep, yeah, replace that with, well, not the string country, you want to replace it with the argument where you're gonna put that, right? So in this case,
It's just place by place.
yeah, so the argument, so it's gonna go at the end is our actual string, but you're in your function definition, you've said whatever the thing called filter value is, filter by that. So whatever you called your like filter value, yeah, exactly, it doesn't need to be in quotes there. Yeah. It's not the string itself, it's just a little placeholder. Right, great, and then you need to do that same thing with country, right? We don't want country, we want whatever, yeah, exactly. There you go, we're like making a generic version, and again, it doesn't need the quotes because it's not a string, yep. Cool. All right, so let's look at what this error is.
Oh, yeah, I just put a, 678,000 each.
Yeah, so we want to pick a text column for that one. We want like philosophy or hobbies or something, because this is a text function. Height's probably a number field, so it's not gonna work. Cool, getting there. All right, and let's go down to the bottom of our error message, just helpful stuff with this. All right, let's come back up to your functions. Look. All right, so my filter function takes my data frame, column name, filter value. We're creating a new data frame called filter df and on line 2. That looks at my data frame and filters it by my data frame, filter name of column equals filter value. Great. Then I'm going to take my filter data frame. Aha. Okay, I think I see the issue. All right. So in that third line that you have, our function should look. All right, so I should be giving it my filter df and then my column name and then close my bracket right there. I think your bracket goes all the way to the end, so it's looking for a column name.
Yeah.
Nope, so your second line is good. We're in your third line. So you're saying in the data frame, filter data frame, look for a column named data frame column name. So we've got an extra data frame in there, right? Because filter df has a column named column name, right? So we don't need the my data frame in there. Yeah. Great, and then I think we have an extra square bracket, and maybe that's that. All right, cool. Does that make sense? So filter data frame just has that same column name. You don't need to access within filter data frame. You don't need to access my data frame, which is what you were doing. Yeah,
I tried to understand.
no, you're good. Okay, there you got it. Okay, cool.
Finally.
Very good. All right, and then try swapping like Ireland or France. Try another country in there, and you should see it change a little bit. All right, like if I change mine, let's see if France works. Think for a second. Amazing. So for France, it comes up with work hard, always. What are those kind of words? All right, so all I did is just change where I'm calling it, right? Should get slightly different. Yeah, cool. All right. Very good. All right, cool. Okay, so this is I would say kind of like an intermediate skill, right? The ability to look at some code. We did this before, right? Look at a chunk of code and you're essentially taking this and making it generic, right? That's the piece we were just talking about, is thinking, okay, where here am I referring to a specific data frame, a specific value, a specific string, and making it generic, putting in a placeholder for each of those so that you can plug in later whatever string or data frame you want, right? So we're going to do one more function that's going to work a little differently. I think this one I think can be a little bit more straightforward to think through because the function part itself is going to be a little simpler and we're just going to apply it differently. So what we're going to do now is create a function that's just intended to run on an individual value. So this last function we just wrote, right, we were giving it a whole data frame column and operating on that column. What we're going to do now is write a simpler function that's just going to take in an individual value, like a number or a string, and give it an individual value back. And then we're going to apply that function so that it gets applied to every single row. Okay, so we're going to kind of flip what we were doing. We're not operating the function on the whole data frame. We're going to operate the function. You can think of it as kind of on one row, and then we're going to apply it to the full frame. Okay, so this is a very simple function that returns a different emoji based on what the numerical rating is. All right, I'm down the road, I'm going to apply this to my rating column and my rating data set, but I'm just giving it a number. I'm just giving it 10 or 11. Okay, so what I'm doing here is it's going to take in rating, which is just a number. And then I'm going to do some very simple if-else logic, which I don't think we talked about this last week. Very common kind of like programming concept, similar in Excel, you can do an if statement. So what I'm going to do here is check if the rating is greater than 9. If it is, I'm going to return this emoji as a string. Emoji is kind of strings. It's very exciting. If not, I just sort of skip this part. I come here, I say if the rating is greater than 7. So it's already checked if it's greater than 9. So this is just going to find out if it's sort of between 7 and 9. Then return the green circle emoji. And if neither of those things apply, it's going to fully skip down here and just return the red circle emoji. Okay, super simple function. So for example, I have it here. So if I call, I guess here I have 7.5, same thing. So I can call my function just like this. Rating symbol 8, that returns green. If I call rating symbol of 5, it's going to return red. Fantastic. And if I put in 10, it's going to return star.
And why is not a star and a green dot?
Ah,
Because like they like, yeah, it's bigger than 9 and it's bigger than 6.
yes, very good question. So anytime the function hits return, it's out, it's gone, it's done. Return is the full stop. Okay, so anytime it hits return, it's just going to be done.
Yes.
So the very first time it hits it, it'll be up. I could have written this a little differently. I could have set a variable that was an empty string. In each of these, I could have updated that string, and then I could have returned just whatever that string was at the end. So I could have just had a single return, but this is doing the same thing. Yeah, so return is just going to fully stop your function wherever it is. Good question. Okay. So once I have a very simple function like this, it's just operating on a number. This function has nothing to do with data frames, okay? I can apply that function to my data frame using a special other function called .apply. Okay, this is like sort of similar to the lambda thing you were asking about at the beginning. So I can take my ratings data frame, my rating column, I can .apply. And then I just give it the name of my function. So I'm not actually telling it any arguments here. Normally I would write a number here. I'm just giving it the function name, but the special .apply is going to take this function name and apply it to the value in every row of the data set in this column. Okay, so it's kind of doing that part for me for every single row. And I'm going to save that to a new column in my ratings data called ratings emoji. All right, so just to show you what that looks like, if I just take out the saving part and I just run it, it's going to give me this result, right? It's going to give me a mix of the 3 different emojis that I defined. Right, in my little preview, still 172 rows. If I add this back in where I'm saving it to my data frame, it'll save it to that column. And then when I preview my data set, I'll see it as a column here, right? So I'll see all the other columns that I had, the new column I made at the beginning, and then I see my red, green, hopefully some stars in there somewhere. All right. Does that kind of make sense? This is like a different way of writing a function, and then where the special .apply thing is applying it. Yeah. Okay, so I'm going to have you all write something similar to this on our Olympics data set. Okay, so your task is to make a function that we're going to be using our medalists data. Medalists data is one of your data frames in your thing. So first I want you to make a function that has nothing to do with data frames, that just takes the whether it's gold, silver, or bronze, and returns a different emoji depending on whether it's gold, silver, or bronze. Okay, so you should have a function that's very similar to this, has a few ifs, a few returns, okay, and just a few conditions for whether your medal in the medalists table is gold, silver, or bronze. Should return a different emoji. All right, so I'll have you start with that, and then once you have a function that's working for that, then we're gonna apply it to that data frame.
There's like in Metalist data, there's metal date type code.
Yes, okay, so you should definitely do medalist data dot head to kind of look at what, do your little
Right.
preview, yeah, look at what your columns are.
Metal.
So here's an example of the, so when you're done with your little function, you should be able to run something like this. So I called mine add metal colors. And when I give it gold metal, it spits back this emoji. You can pick whatever emojis you want.
I mean, Windows. Don't have to-
Okay, oh yeah.
Um, It's like when I use the head function, that's everything just like stuck together. So
Mhm.
I can't really read.
It should be head, open parentheses, close parentheses. Should get showed up as a proper table. Yeah, try that. There you go. Yeah, I didn't actually know it worked. Looks like it's doing something weird. Okay, so you should be writing a function that looks very much like this, that we could call kind of like this. Get back a different emoji based on gold, silver.
example give about like how to add column?
So you don't do anything with the column yet. All you need to do right now is this part. Yeah. So you should have a function that looks very much like that, but it's looking for whether the value is gold medal, silver medal, or bronze medal. It should return a different emoji in each case. All right, so let me know when you have something like that. Do that first, and then we'll get to the apply.
I got it, and I
Yeah.
got an arrow.
Okay, let's see what you got.
They said like valid syntax.
Okay. Great. I think I see. So do you see how in this return line, your quotes are red, like your strings are red in your first several lines, and then in this last one, the string is not red. It's this last, the little marks are black. These ones are a little different for some reason. So grabbed. Yeah, so that's good. So it's only off on your last one. Your first four are all, this like top of is red, which is what it is for the strings, and then this last one's yellow.
You should say.
No, that one's fine.
No. And this one?
No, that one's good. That one's good. You can
Okay.
leave it how it was. But that last one, I think you maybe hit this character instead of this character.
Oh, yeah.
All right, try
Right.
that. Okay, get rid of this last line. I don't want to do that
Okay.
part yet. Here you can just put a pound sign in front of it that'll comment it out. Yeah. Okay. All right. Great. Okay. Perfect. All right, and then the very last thing is for your if lines, you need, I think that's maybe what you just said. After the end of your if lines, you need a colon.
Oh, yeah.
Yeah.
I-
You're good. Same as
Okay.
definition. All right, give that a run.
Okay, I think
That should probably be good. Okay,
Yeah.
and then do a new cell and then try, and then you should be able to run something like this and make sure you get your emoji back. All right, make sure you can do that and get something. Just call it in a different cell and make sure you get your.
Is that a test line? Or
Yeah, exactly. So you just want to be able to call it and then give it a string. And just make sure you get the emoji that you're expecting. I can test mine again and make sure, like if I type in silver medal, my emoji should change. I'm gonna change that silver. Okay, perfect. Great. Cool. All right, so I think you both have something kind of like this, right? So we have our little definition. Yours worked right when you called it? Yeah. Okay, perfect. So next thing we're gonna do is now we're gonna do the apply part, okay? So now I want you to add a sort of apply that function to your medalist data frame, all right, to the column that tells you which medal it is, and then save that result to a new column called medal emoji. Okay, so you should have a result that looks like this. So after I did this, I have medalist data.head, and then I have my new column that puts the emoji in for each one based on the column that tells me which medal, which I think is called medal type. Okay, so you'd want a line that looks something, you want a line that looks something like this. Okay, so you want to apply your medal function that you just made to the medalist data medal type column, and then save that to the medalist data set in a new column name. Okay, so this is my example from the ratings data. You want to do this with the medalists. You got it? All right. It all lines up. You got the right emoji on the right row?
Yeah.
Okay. Very good. That's okay. All right, you got it? Okay, very good. So you probably have something that looks like this, right? So our metal type column dot apply, name of your metal function, saved to a new column. Very cool. Okay, so we covered a lot of stuff today. The two kind of main pieces that we covered are within functions. So how to write your own function, and then how to use your function on a data frame, either by taking your data frame, just feeding your data frame into your function and having your data frame spit out, in our case, a word cloud. You could also have it spit out just another modified data frame. And then we wrote just a regular old function. So just a function that took in a number or a string and returned a number or a string, very simple function. And we used dot applied to actually have that run on each row of our data frame and return a result. So you can operate either way, depending on what you want to do. I find that kind of some folks tend to sort of like think of it more on this level. So it's easier to think of the function on sort of a one value basis and then go and apply it. Some folks kind of think about the whole data frame at once. Both can work. We could have done this in sort of, could have written the two functions that we wrote in the opposite sort of ways, but wanted to give you an example of both. That's all I got for today. So next week is the last session in this series. So what we'll do next week, hopefully we get some more folks, is combine the SQL piece that we talked about in the first couple weeks, the Python piece that we've talked about today and yesterday and last week, and some of the visualization tools that are built into Hex. So we'll talk about kind of combining all of that together, creating a little dashboard. Cool. Well, thank you both for hanging around. Any questions about any of that? Any stuff? All right. Cool.